Let us now find out the capacitance of parallel plate capacitor. We know that the steps to be followed to find the capacitance, what we need to follow is V, potential. We have to find out the potential. Now we know that potential is related with the electric field and the distance by the relation E is equal to minus dB by dr, right? Or we can say, if we ignore the negative sign because it shows the decrease in potential, but here we are not dealing with such situation, so we can say V is equal to E into D. Why D? Because D is the distance between the potentials, distance between the plates, and E is the electric field. So if we can find out the value of E, then putting the value of E we can find out V, and putting this value of V here we can find out C. These were the steps to be followed to find out the potential, to find out the capacitance of a capacitor. Here when we are dealing with the parallel plate capacitor, either we are dealing with the plate capacitor having dielectric, having conducting plate in between the plates of the conductor. So whatever is the arrangement, we need to find out the capacitance. We can use this method. Firstly find out V, then find out E, then put in value of V, and then find out C, right? Let us follow these steps and find out the capacitance of the capacitor. Here you can see that what I have made is a parallel plate arrangement of the capacitor, in which there are two plates, plate 1 and plate 2. Plate 1 is having positive charge density and plate 2 is having negative charge density. By viewing this arrangement, you must be in recapitulation of the topic in which we have find out the electric field and density due to two thin parallel plates. In that case, we have studied that to the left side of the plate, value of E is 0, and to the right side is also 0, but in between the value of E is equal to sigma upon epsilon naught, right? So in that case we can write that E is equal to sigma upon epsilon naught, or sigma can be written as Q upon epsilon naught into A. So E we have find out. Now what we need to calculate? We need to calculate V. V is equal to E into D. So putting the value of E, it is Q upon epsilon naught A into D. So V we have calculated. Now where we have to put? We have to put C is equal to Q by V, or Q upon QD into epsilon naught A. So Q cancels, so we get C is equal to epsilon naught A by D. So this is the capacitance of the parallel plate capacitor. This is the case when we have considered that the medium in between the plates of the capacitor is air, means free space. But what happens when some dielectric medium is introduced between the plates of the capacitor? In that case, this expression will change into C is equal to epsilon A by D. Now we know that relative permittivity epsilon R is equal to epsilon by epsilon naught, right? Or we can say that epsilon is equal to epsilon R into epsilon naught. So putting this value here, C is equal to epsilon R, epsilon naught A by D. So what is this? This is C naught. Suppose here I put this naught factor. So C is equal to epsilon R into C naught. Now also we know that epsilon R is equal to K, which is the dielectric constant C naught. So we can say, by introducing any medium in between the plates of the capacitor having dielectric constant K, its capacitance increases by factor K. Just have a recapitulation. Force decreases by factor K, electric field decreases by factor K, but capacitance increases by factor K, right? So this is the effect of the dielectric medium in between the plates of the capacitor.